the key: integrating diverse data. Whatever your big data application is and the types of big data you're using, the real value will come from integrating different types of data sources and analyzing them at scale. So how do we start getting this value? Sometimes all it takes is looking at the data you already collect in a different way, and it can mean a big difference in your return on investment. This news story from June 2015 mentions that Carnival Cruises is using structured and unstructured data from a variety of sources. Carnival turns it into profit using price optimization techniques on the integrated data. For you to achieve such a success story, you will need to include data integration into your big data practice. However, there are some unique challenges when attempting to integrate these diverse data sources and scaling the solutions. Course 2 in this specialization will teach you more about these issues. But let's take a moment to define why effective data integration is useful. Data integration means bringing together data from diverse sources and turning them into coherent and more useful information. We also call this knowledge. The main objective here is taming, or more technically, managing data and turning it into something that you can make use of programmatically. A data integration process involves many parts. It starts with discovering, accessing, and monitoring data, and continues with modeling and transforming data from a variety of sources. But why do we need data integration in the first place? Let's start by focusing on differences between big data sets coming from different sources. You might have flat file formatted data, relational database data, data encoded in XML or JSON, both common for internet-generated data. These different formats and models are useful because they are designed to express different data in unique ways. In a way, different data formats and models make big data more useful and more challenging all at the same time. When you integrate data in different formats, you make the final product richer in the number of features you describe the data with. For example, by integrating environmental sensor and camera data with geographical information system data, such as in my wildfire prediction application, I can use the spatial data capabilities with non-spatial data to more accurately run fire simulations. In the past, although we were able to see the images of a fire from mountaintop cameras, just like this image, we were still not able to tell what the exact location of the fire is automatically. Now, when a fire is detected from a mountaintop camera, viewsheds are used to estimate the location of the fire. This location information can be fed into the fire simulator as early as it's detected to predict the size and location of the fire in the next hour more accurately and faster. Similarly, I can use real-time data with archived data sets and use them all together. Additionally, by bringing the data together and providing programmable access to it, I'm now making each data set more accessible. Moreover, integration of diverse data sets significantly reduces the overall data complexity in my data-driven project. The data becomes more available for use and unified as a system of its own. One advantage of such an integration is not often mentioned. Such a streamlined and integrated data system can increase the collaboration between different parts of your data systems. Each part can now clearly see how their data is integrated into the overall system, including the usage scenarios and the security and privacy processes around it. Overall, by integrating diverse data streams, you add value to your big data and improve your business even before you start analyzing it. Next, we will focus on the dimensions of the scalability and discuss how we can start tackling some of these challenges.